good morning, good afternoon, and good evening. To those that are coming back, welcome back. And to those that are new, welcome to my YouTube channel. Do not forget to subscribe, share, and leave a comment. In today's video, we are going to be looking at locus. When we speak of locus, we are talking about a set of all possible points whose location satisfies a given condition or perhaps given conditions. We have about 4 conditions, and as we continue, you might hear me referring to them as descriptions. There are 4 descriptions / conditions that we are going to be looking at, and we have to make sure that we understand them as individuals before we attempt questions that are kind of exam examples when they are combined. But remember, we said we don't only expect one condition or description, we can get more than one. Now, why is this important? Why is this topic important? For example, for those future engineers, or even just you as a person that will perhaps in future own a plot, you want to understand the concept of construction, so that when you are constructing your house and you have to, or you want to put your pool or swimming pool in a certain position in your flat, you are able to locate it in a way that it does not interfere with perhaps your pipes, your electricity cables underground, whatever. So these are the reasons that you need to understand this concept. Now, very important, we said we are going to be looking at 4 conditions or descriptions that we can possibly get and that we need to understand as individuals before we go and combine them. I've written them down here. Excuse my handwriting. It's the position of the paper, I guess. Or maybe it's just my handwriting. Now, the very first condition is when you are given or when you are coming from one point. When you are coming from a given point, meaning 1 point, you could also refer to this as 1 point, coming from a given point or 1 point, meaning you are just coming from 1 point, not 2. Now, what do? We have an example that is going to help us understand what you do then. Remember, we said we are trying to construct a locus or a set of points that satisfy the conditions that are given to me. So therefore, whatever I'm going to construct should be correct, should be true. Now, the very first condition, back to the description, they are saying construct a locus of points that are 3 centimeters from point A or from A. So what do you need? You need a pair of compasses, a pencil. It's not a pencil, but just for the purpose of you seeing very clearly. And then you need a straight edge, also known as, aka your ruler. Now, how do you do this? What you're going to do is you take your compass, your pair of compasses, you make sure that your sharp end goes to 0, exactly at 0, and then you move your pencil to 3, so that the distance between your sharp end and your pencil is exactly 3 centimeters, nothing more, nothing less. And when you are satisfied with the condition and you see, or the position, not condition, you then are allowed to remove your ruler, and then it means that the distance between the sharp end and your pencil, we are calling this our pencil, is going to be 3 centimeters. So now what do? You will come and you will put your sharp end exactly at A, put your sharp end at A, make sure it's exactly in A, and then you go and draw. Preferably, do not go through again, because you make the line thicker and you go beyond the measurement. Also, don't press too hard, because you might move your compass and then changing the distance between the sharp end and the pencil. So you then start, you go around, come around, come around, come around, and you are done. What does that mean? It means from the center to the circumference of the circle, you have 3 centimeters. You can measure it from a different angle or different side. You will see it's 3 centimeters exactly. You go to the other side, you try and just test, to just see, is this correct? It is indeed 3 centimeters. And this is now the locus, or the set of points that are going to be 3 centimeters from point A. And relating this again to the definition that we have looked at earlier, is that a locus, which is what we have constructed here, is a set of points. And we have in the previous grade been taught that a line or this arc is a set of points that makes up this arc or line. that are now satisfying the given condition. What is our given condition? 3 centimeters from A. Okay, so that is when you are coming from 1 point. Okay, then we move to coming from 1 line. When you are coming from 1 line, you're coming from a line like in the given case here, where you're coming from line AB. So the question will come like, construct a locus of points that are 1.8 centimeters from line AB. So what do you need in this case? You need a straight edge. So you will come, then you will measure from this. I want to measure now 1.8. Now, why am I using the x's for the millimeters? Because if I go to the centimeters and I put the 0 exactly there, I know 1.8 is somewhere in this area, but I don't know exactly where, which is quite a risk because we said in construction we want to be as accurate as possible. So it's rather safe because I know 1 is equivalent to 10 millimeters, 1 centimeter. 2 centimeters is equivalent to 20 millimeters. 3 centimeters is equivalent to 30 millimeters. So since this side is actually detailed, the scaling is in much more details, then I'm able to depend on this much more because then I'll be able to locate 1.8 meaning 18. So if this is 10 meaning 1, then here I'll have a 15 which is 1.5, and therefore 18 will be exactly there. Make sure you don't move your, so you make a point there. Then you come in the middle, measure again. You measure again, 1.8. You'll be somewhere around this area. You'll come again at the end, 1.8. Just for accuracy, you come. Now you take your straight edge and you come and connect all these lines that you have drawn here. And you'll say, oh, so it means everything in this area, from this point to this point, will be 1.8 centimeters. From here to there will be, from here to there will also be 1.8 centimeters. From there to there will also be 1.8 centimeters. So that's what it means. But it means then, if you're coming from a line, then you're going to draw a line that is parallel to the given line, but then it should be the distance that you're given away from the original line. And now you're not done, because those are not the only points. There are 1.8 centimeters from the line AB. So you need to go on the other side as well. Then you go and measure again. So I'll go measure, and I'll say, okay, I measure 1.8 because the ruler won't fit that side. That's why you see I'm measuring from this angle. So I want to go until 18. So it means 2 blocks before 20 because I'm using the detailed side of the ruler. So it means then the line must start there because it must always start at 0, right? I go in the middle. I do not want to excuse myself in the middle because I want to make sure. Because I mean, I'm writing an exam that determines the rest of my life. Why take chances then? So then I move to the last part. I'll then go and put point there. Then what is that for? Just to guide me and say, oh, the second line is here then. And it means everything between this line and the original line AB is going to be, but of course until the end, is going to be 1.8 centimeters. Everything between the given line and the original is 1.8 centimeters. Everything in the given line is 1.8 centimeters. Now, the interesting part is that we have kind of excluded something there, which I do not want as your teacher to exclude, because then you are not really accurate. Because anything from this point to that point is 1.8, right? So then it means we have something that is also 1.8 from, yes, point A, but point A is part of line AB. So just like this part is part of line AB as much as it's not, fully. So everything on that line will be 1.8 from that line. So now we can go on the other side as well. And then we start on the side of the points. We make sure we have positioned our pencil well in a way that is stable. If you find that it's not stable, then maybe you should move it down a bit. So you come and you measure 1.8, remember to use the reliable axis, the detailed axis. So you come and measure 1.8, meaning from 0 until 18. So you measure 0 until 18. I see, oh, my pencil is too low, ne? So it means it must go at least up a bit so that it's not exceeding the sharp end. Then I'm going to say, okay, 1.8, where are you? Here. So that is exactly 1.8 because that's exactly 18. Therefore, I'll come and say then, from this side then, I must also be able to connect these ones. Then it will be 1.8 as well as this one. The position that I'm in now is a bit scary, but as well as, oh, that's why you should use a pencil, eh? Because it can become very messy if you use something. Ooh, my apologies. You are done, please. Yeah, but don't go beyond to create a circle. You're just connecting that. And it means this is also 1.8 centimeters from there, 1.8 centimeters from there. So then you have included everything. That is it. That is the second part, right? We move to the next one. And the third one is when you are coming from 2 points, also known as equidistant from a point B and A or C and D, whatever the letters. Now, another way to refer to this is what we call, or we refer to this as the perpendicular bisector. It's another way to refer to this. Now, what does perpendicular bisector mean? Perpendicular, we all know, 90 degrees. Bisecting or bisector means dividing into 2 equal parts. If I have to bisect something, it means I'm dividing into 2 equal parts. So now how do I do that? We do not measure anything here whatsoever. We just estimate. You take your compass, you come, and you make sure that you put your sharp end on one of the points. You make sure that you move the pencil away much further from where you put the sharp end than much further to the other point, to the other side than to this one. Don't be too in the middle or too close to this, because then there's no point in doing that. Then what you will do then is, after making sure that you're much closer to the other point than to where you're coming from, you then draw your arc like that. Then you don't change the size. You come on the other side. Make sure you put it on the side of A. You come and you draw another one there. So then what do? You take your ruler, then your ruler and your pencil, you connect these intersections. You connect them. So this line that is connected through these intersections is going to be a line that will be perpendicular to AB. Not only is it perpendicular, it bisects the two, or the line, meaning it divides the line into 2 equal parts. So if this is 5 centimeters, this is also 5 centimeters. That's why we are saying equidistant from A and B. We used A and B just so that you can see the difference between the other questions or the other descriptions that we have done before. I didn't want to use C and D. I want you to understand that there's a difference between these descriptions. So far we have looked at 3. So remember, I'm repeating, if I say equidistance from C and D, I mean the same thing as construct a perpendicular bisector of the line CD, because this line is also AB. So if I say perpendicular bisector is this line, meaning a line that is perpendicular to the given one, but it's also bisecting, meaning dividing the two into equal parts, right? So meaning anything on this line, if it's going to be 8 centimeters from that one, then here it's also 8 centimeters from that one, because it's equidistant, right? That is when you're coming from 2 points. And the very last one that we are going to look at is when you come from 2 lines. We have an example there, and we want to make sure that we tackle this one and we understand it, so that when we go to the detailed questions now, the exam kind of questions, we are not going to lose it. We understand. Okay, so the very last one is when you are coming from 2 lines, which also refers to the same thing as equidistant from AB and BC. This is AB is a line, BC is a line. That's why we are calling it 2 lines. Another way to refer to this is bisecting an angle. Bisecting an angle. What does that mean? Remember we mentioned earlier that bisecting means divide into two equal parts. So if we are bisecting an angle, then it means these two lines create an angle that we will then divide into two equal sizes. So if it was 60, we divide 30, 30. But we are not doing any measurements here. We just use our compass. So how do we use our compass? We first want to identify. So you use your compass. We are not measuring anything, I repeat. We don't want to measure 3 centimeters or whatever. So what we are going to do is we go and locate or try to see where is these two lines. Where do they meet? Which angle do they create? So AB is this line, BC is this line, meaning we are bisecting this angle. So how do you do that? You take your sharp end and your pencil, make it much closer, but not too close. The idea is to construct something like you go to the corner where the angle is formed, and then you create an arc this side, and the very same distance you use on the other side. You don't measure, you don't change. But if you want to be so accurate, you could have also just gone and you connect them. I don't want to redo that because it will look messy. So make sure that there's no shaking, the position of the table, unfortunately, but we don't want to be shaky. So now after doing that, you can then, you are not measuring anything, you just extend it a bit. You extend it a bit, but in a bit such that you want to create another intersection here. So after extending it, you come and put your sharp end on the arc you created on one arm of the angle, which is either BC or AB. You come and create an arc there, and you come and change it. Don't change the size. Go to the other arm. Make sure you are where the other intersection is, where you drew the first arc. Then they will intersect somewhere. What does that mean then? It means if I connect the intersection I've just created to the vertex where the angle is that I'm trying to bisect, then I have divided that angle into two equal parts. But we don't end at the intersection. The intersection is just to guide you, to say where should your line go through. But it's not to end there. You go, especially when they give you a box like that. They sometimes add here that inside the given shape, inside the given four-sided shape or quadrilateral, then you come and you draw your line there. And you want to make sure that you have indicated. Don't make it too thick, because then you make it thicker. Now we don't know which one is accurate, right? Now, please, I repeat, do not just end at the intersection. Go beyond if you have, or if you are bounded, by this. Because if you wanted to maybe try, if we are saying it's a construction and this is your plot, and you want maybe to construct, maybe it's steps to go to the other small gate. Now, if you end there, how do you know where you should go here now to go and locate your... So, at least it's important to go until where your plot ends. So, that is very important to understand. Please don't forget to pause. Don't forget to repeat the video if you need to. Don't forget to pause and try again yourself. Draw your own things and then try again. Just to make sure that you have laid a strong foundation for the kind of questions that we are going to be dealing with when we go to the exam examples on these questions, because now we are going to combine them. We are going to combine all this, and then we are going to get maybe a position or locate a position on your plot where you want to go and construct perhaps your garden or something like that. Real life situations that we're going to be doing. And for you to be able to deal with that, you want to make sure you have practiced enough and well with this one. Now, another important thing that I should mention is that, please, very important, very, very important, you don't wait until tomorrow you're writing math for you to get yourself a compass. If you are in Namibia, there are compasses that, or not compasses, but a math set that they are selling in PEP that was affordable, but yet valuable, yet very, very comfortable, very, very less risky. If you buy the one for $9, it might just last you the exam when you are preparing, or the one exam, but then end of the year you might be struggling again. I repeat, don't wait until you're writing your national exams for you to go to school and start asking for a compass, because then you're not serious with your life. Because you need to practice with these things. These are not things that you just wake up and be able to just move the compass. You will be there shaking and trying to hold the compass as if you are trying to fight it if you do not practice well. So please do take that advice. Thank you for watching. In the next video, I'm going to look at an exam example, and then I will do it with you. Then I'll take a video of one of the examples that you can do yourself. You try to do it, and then I'll make a video again for the solutions on that, and then move on to the next section. Please Stay tuned. Don't forget to subscribe, share, like, comment, of course. And thank you for watching. Bye.